Hi there, I'm going to work through some National 5 revision questions today, and these questions will prepare you for the quizzes that have been set to follow this, okay? Now remember, these quizzes, they are multiple choice questions. However, you will need a pencil and paper to do some working so that you can work out the answer, okay? Right, the first few things I want to go over are on Certs, okay? Now, just a quick reminder, you should be able to simplify a cert. Okay, you should be asked, or you should be able to rather, you should be able to simplify a surd like this. Okay, this is a surd because you don't actually know what the square root of 27 is. Okay, root 25 you do know what the square root of 25 is, but this is root 27. Now to simplify this, remember what we do is we need two numbers that multiply, two numbers that are factors of 27. Two numbers that multiply to 27, but we need to know that one is a perfect square number. Now, just as a reminder, what are our square numbers? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16. Whenever you're doing your simplifying surds, it's handy to have these numbers either in your head or you can write them down. 5 squared, 6 squared, and so on. Okay, so to simplify root 27, we're looking for two numbers that multiply to 27, and one of them is one of these numbers, one of these square numbers. 9 goes into 27. So what we write root 27 as? Root 9, but what's the other number that multiplies with the 9 to make 27? 3. So it's root 9 root 3. Now we put the root 9 first, the one we know is a perfect square. We put root 9 first because we know the square root of 9 is 3. We don't know the square root of 3, the next bit, so that just stays the same. Okay? Right, what you'll also be expected to be able to do is some addition or subtractions with surds. So for example, a question like this. Okay? To do this, we need to simplify both of these surds first. So just as the same as I done the first time, okay? Two numbers that multiply to 12 and one needs to be a square number. Please go for the highest possible square number that goes into 12. 4 threes are 12. 4 is the highest square number that goes into 12. So we can write it as root 4 root 3. But the root 4 is first because we know the square root of 4 is actually just 2. So that's a 2 root 3. Now I'm going to do the same with the root 75. Two numbers that multiply to 75. 1, the first number, has to be the highest square number that goes into 75. 25. 25 times 3 makes 75. So because 25 times 3 is 75, we can write root 75 as root 25 root 3. And we put your root 25 first because you know the square root of 25 is 5. So it's 5 root 3. And then at the end you'll notice we've got 2 root 3's add 5 root 3's. 2 of them and 5 more, you've got 7 root 3's altogether. Okay? Right, other types of questions that you could be asked involving surds is an example here. Rationalise the denominator. That basically means get rid of the square root on the bottom. Now the method that we use to rationalise the denominator is we multiply by, and you should be working a wee step ahead, by root 6 over root 6. Now you'll notice I've penciled in the bottom one first. Whatever the bottom here is, root 6, which it is in this case, we multiply by root 6 again. Now the reason we do that is because when you multiply root 6 by root 6, you get root 36. 6 sixes are 36, you get the square root of 36, but the square root of 36 is just 6. If the bottom was root 2, you'd multiply by root 2. Root 2 times root 2 is 2. If the bottom was root 3, you'd multiply by root 3. Root 3 times root 3 is 3. Okay? Now you'll notice we multiply by root 6 over root 6. Top and bottom must be the same. So at the top we've got 9 root 6. 9 times root 6 is 9 root 6. However, it's not finished. Be very careful when you're simplifying your surds because the whole number can get simplified with the whole number on the bottom. So we can do a wee bit of simplifying with the 9 and the 6. Not the root 6 and the 6. The 9 and the 6. Divide them both by 3. So it's going to be a 3 at the top and a 2 at the bottom. So 3 root 6s over 2. That's the final answer. Okay. Another wee bit, we're moving on to a wee bit on indices now. So you will get a Certs question, you'll get an indices question. When you're multiplying with the indices, this little letter A here doesn't have a number at the top, it doesn't have a power. Remember, it is a power of 1 if there's no power given. So at the top, whole numbers multiplied is just a number 3 at the top. What happens with the a to the power 4 and the a to the power 1? The rules of indices tell us that we add the 4 and the 1. When you're multiplying like that, we add the 4 and the 1. So it's 3a to the power 5. Now on the bottom, it's root a. Now there's another way of writing root a. It's a to the power something. Now the square root of a is the opposite of a squared. Right? A squared is a to the power 2. The opposite, the inverse. The actual power is a half. Please remember that. Okay? If it was the cube root of a, that's actually a to the power a third. So have that in mind. Might need it for your wee quiz. Okay? So I'm just going to change the bottom to the a to the power a half then. And now this is a division. The rule for division, 3's not doing anything, it's still there. The rule for division is that you subtract the powers. 5 take away a half is to the power 4.5. You can write it as 4.5. You can write it as, if you wanted, you could have had 3a to the power 4.5. Or if you wanted, you might have wanted 3a to the power 9 over 2 is 4.5. It doesn't matter which way you write it. That's a 4.5 there. Okay. And a wee next question, this is a wee bit on fractional powers. I did touch on that in the last one, okay, we did mention that. To do this, the 5 at the top stays where it is. Now I've actually just mentioned on the last question the 3 at the bottom. The 3 at the bottom is to do with the cube root. If it was a 2 at the bottom, it would be to do with the square root. So to get the answer to this, it's the cube root of 8. What number cubed gives you 8? 2, because 2 times 2 times 2 is 8. But then we have to do that to the power 5. 2 times 2 times 2 times 2 times 2. Don't know how many 2's I said there, but sometimes it's easier to see it like that. You don't need to write that out, okay? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. It's easier to do than try and just get a work in your head. Okay? A wee reminder here at the bottom, anything to the power 0, 5 to the power 0, 12 to the power 0, anything at all, x to the power 0, the answer is always 1. Please remember that. Okay? Right, a wee bit on straight lines and equations now. So, find the equation of the line. Right, the equation of any line is always y equals mx plus c. All these equations that I'm going to put on in this question, nothing is on the formula list. You must know it. Now, to work out m, which is the gradient, remember the gradient formula, y2 minus y1 over x2 minus x1. Okay, please label the points. Choose one of your points as x and y number 1, and choose the other point as x and y number 2. So, y2 is 15 take away, y1 is 5, over x2 is 3 take away, x1 is negative 2, so I'll put it in a bracket. So it's 10 over, remember 3 take away negative 2 is 3 add 2, so that's a 5. So 10 divided by 5 is 2. So the gradient is 2. So this equation is y equals, instead of mx, it's 2x plus c. There's a couple of different ways to get your c value. It's a couple of different ways to get the equation of the line. One simple way, I'll do it a nice simple way, which involves subbing in a point. Okay, you can use y minus b equals m bracket x minus c to do the equation, or you can use this method. I'm just going to sub in the point 315. I'm going to sub that in as my x and y. And if I do that, that'll tell me what c is. So y is 15. 2x. 2 3's. Add on c. So basically I've got 15 is equal to 6 add c. It's very simple to see and work out what the c value is now. If 6 add c makes 15, then c is 15 take 6. C is 9. So remember the equation of the line y equals mx plus c, y equals, the gradient was 2, and the c value is 9. Make sure you write your equation at the end. Don't just leave it with your c values and your m values. Okay? Another wee bit on equations of straight lines. Find the gradient. Remember, the gradient is the value of m when the equation looks like this. That's the gradient. That equation that we've been given doesn't look like that. So what we need to do is we need to do a wee bit of rearranging the equation to make it look like y equals mx plus c. So I'm going to change this about. I'm going to keep the y's on this side because I want y on this side. I'm going to move the 3x's across, and I'm going to move the minus 10 across as well. If I move the 3x across, it becomes a negative 3x. If I move the minus 10 across, it becomes a plus 10. And now I'm going to work out y. How do I get rid of the negative 5? I am dividing by negative 5. I'm going to divide all of this by negative 5. Now, if I divide all of it by negative 5, it's basically going to give me negative 3x over negative 5, and it's going to give me a positive 10 over negative 5. Now, I don't really need to do more than that. The gradient is what's in front of the x, the coefficient of x. How many x's have we got here? Well, it's negative 3 over negative 5. Don't leave it like that. It's actually just 3 over 5. Do not write the gradient with an x in it. It's not 3 over 5x. It's just the 3 over 5. So the gradient of this line would be 3/5. Right, a few wee bits on quadratics now. Quadratics, here is the equation y equals kx squared. We've been given a point on the graph. A standard method that we use in a question like this. Here is the equation. We've been given a point, 2 negative 16. If you know a point and you know the equation, you can sub the equation, or the point rather, into the equation. So I'm going to say y is negative 16 equals, remember kx squared means k times, what's the x squared? 2 squared. So basically this means negative 16 is equal to k times 4, because 2 squared is 4. So really what I've got here, I'm just going to put the equation round like this. Okay, I prefer the unknown letter to be on my left-hand side, which is what I done in the last question as well. So k times 4 equals negative 16. How do I work out what k is? Well, it's negative 16. How do I get rid of this times by 4? Divide by 4. So 16 divided by 4 is 4. So negative 16 divided by 4 would be negative 4. So k is negative 4. That's the value of k. Another parabola, one like this. Right, okay, find the values of a and b. Right, a and b, remember, in this equation, the a and b are to do with the turning point. Okay, the value for a is basically how far along, left or right, has it been moved. And when I say has it been moved, I am referring to the normal x squared graph looks like that, and it goes through 0, 0. Right? This graph has been moved along that way, and it's been shifted down the way, okay? So it's to do with these numbers here. Now you should have already worked them out, I hope so. A is basically, well, this is the number 2 here, because the coordinate of the turning point is at 2. But a is not positive 2, a is actually negative 2. The value of b, well, b is down, it's been moved down the way. The coordinate here is negative 4, because the coordinate of the turning point tells us it's negative 4. So that means, that's a negative 4, b is negative 4. What is the equation of the axis of symmetry? The line of symmetry goes straight down the turning point. The equation of the axis of symmetry is basically what number does it cut through? It cuts through the number 2 on the x-axis, so it's x equals 2, not negative 2. Okay. This one just looks like an upside down version of the last parabola. This is a maximum turning point. How does this change the equation? It sticks a negative in front of the equation to flip it upside down. It tells us, here is the equation. Oh well, that's part B. Let's have a wee look at the start. Right, the turning point has a coordinate of 420. What's the equation of the axis of symmetry? We've done this in the last question. The line of symmetry goes straight down the turning point, and the equation is basically, what number does it cut through here? It cuts through the number 4, because the parabola coordinates of the turning point tells us it's 4. So that's number 4. So the equation is, remember, x equals, it's an equation. X equals, what number does it cut through? X is 4. Right, part B. This is what I was referring to. Stick a negative in front of the x part with the equation. It's already been given there. So what are the values of A and B? Same as the last question. A refers to across the way. It's positive 4, so A is not positive 4, A is negative 4. And the B refers to this bit. It's moved up 20, so B is just 20. It's not asking for you to write the equation, but if it did ask you to write the equation, you just put your numbers in the right place. That's what that equation would actually look like. But most times it just asks you to put in A and B. A wee bit on completing square. Complete the square, half it, square it, subtract it is the method that I would be using. Half it, square it, and subtract it. So, in the brackets, it tells us it must look like this. So it's an x plus or minus something. I know it says x plus a, but it depends on this here. So it says x squared plus 8x. This is where the half it bit comes in. We're not writing plus 8x. We're not even writing with an x. It's x plus 4. Remember, it has to look like this. Half it. So we've half the 8 is 4. Half it. That's done. Square it. I'm going to square the 4. 4 squared is 16. But I need to subtract it. This can be done in a couple of different ways as long as you get the correct answer in the end, okay? We've not dealt with the 7 there, so this wee minus 7 here, please don't forget it. The actual answer is x plus 4 in the bracket squared. Don't forget the squared or you will lose the mark. Take away 23 in total. Okay? Last bit on changing the subject. I think we've only got 1 or 2 questions. Changing the subject, and then you're going to try the quizzes. Okay, there are 2. They're just split up into a couple of different topics. Change the subject to x. So we want to rearrange it to x equals. Now, I like to have x on the left-hand side. So the first thing I'm going to do is I'm just going to switch the whole equation round like that. By doing that, it doesn't change any pluses to minuses or anything. Okay, I've switched the whole equation round. Right, I want x on its own. What has to go first? What is not attached to the x at all? The plus h. That is what's going first. Where's it going? Plus h, minus h. What's next? We've got a g that's stuck to the x, but we've also got a square root that's stuck to the x. What goes first? The g goes first. What is the g doing to that square root x? It's stuck to it, it's multiplying by. So the reverse of to multiply is to do a division by g. And we're almost there. To get x on its own, we've got root x. How do we get x on its own? We do the reverse of the root, reverse of the square root, which is square the other side. Square the other side, not square root. To show that you're squaring the other side, put it in a big bracket and put squared outside. Okay? If you had not done the bracket and left it like that with the wee squared up there, that is wrong. That basically looks like y minus h squared. So all of it is squared. Last one, change the subject to k. So first thing I'm going to do is what I've done the exact same last time. 4, that's a k, doesn't look like a k. Right, I've got k on the side that I want it to be. Right, be careful. What moves over first? We can't put the minus p across first. The minus p is underneath the square root sign. So, to get rid of that big square root sign first is what we need to do. as a subtract. Looked a bit messy. To get rid of the square root sign, we just talked about that a minute ago, we square the other side. That's a bit better. To get rid of the minus p, that's going to go across first. It's not stuck to the k at all. Plus p. And now we can actually get k on its own in one step here. The 4 and the t are doing the exact same thing to the letter k. They're multiplying by the letter k, so we can actually take them across at the one time. Because they're doing the exact same thing, they're multiplying. Now we divide by, was it 40? Get rid of the 40 by doing a division by 40. And that's us. Okay? I've sent you questions that are very, very similar to these. There's 2 quizzes. Okay? Best of luck. Remember, use your pencil and paper to help you. And ask for help if you need it, but use the screenshots